Previously, I had discussed with you about the electric dipole. An electric dipole is a type of a system where we have two charges equal and opposite. And I also told you regarding the strength of the dipole, which was the electric dipole moment, and it was given by P is equal to twice AQ, where twice A was the distance between the two charges. Now, as we did before, we took a charge and we started analyzing the characteristics of those charges. And now I have a particular system which is known as the electric dipole, which comprises of a negative charge and a positive charge. So now what I have to do is I have to find the electric field by this dipole comprising of a negative charge and a positive charge separated by a small distance. My aim now is to find the electric field produced by this dipole at a particular point. Anywhere within that dipole, I have to find the electric field. So in that regard, we select two positions with respect to the dipole in order to find the electric field produced by the dipole. The first point would be the axial point, which is to find the electric field produced by this dipole at a point P, which is with respect to this dipole, as if it is parallel to the dipole. And then at the equatorial point, which would be something like a perpendicular with respect to the dipole. Here it is kind of a parallel with respect to the dipole, and this is perpendicular with respect to the dipole. In the axial case, we take one particular point P at a distance x from the origin O, and we try to figure out what would be the electric field at this point P due to this dipole. And then in case of equatorial line, we select one particular point P which would be normal, that is perpendicular to the dipole, and from the origin O at a particular point P we take it the distance to be x. Out here, E1 is the electric field produced by Q1, since according to the negative charge it is towards the negative charge, hence E1 will be towards. And E2 is the electric field by plus Q charge. Since it is a positive charge, therefore it is going to have an electric field away from it. So E2 is away from it and E1 is towards it, that is for the negative charge. So this is the picture for axial line, and in this case this is going to be the direction of the electric field by plus Q, and this is going to be the direction by the electric field of minus Q. So from here on we start with the axial line first, and then we'll go for the equatorial line. In the case of axial line, we have minus Q at point A and plus Q at point B, with O being the center between minus Q and plus Q. Twice A is the distance between the two dipoles, and X is the distance from the center of the two dipoles to the point P. The point P is the point where we have to find the electric field produced by this particular dipole. So in that figure, E1 is the electric field due to minus Q at point P. Here E1 is the electric field due to this minus Q. As you can see that this arrow is pointing inwards, and we had discussed regarding one particular property of electric field lines, which was the electric field lines is inward in case of negative charges and outward in case of positive charges. Hence you have E1 acting on this side, that is towards the negative charge, where E2 is the electric field by plus Q acting at point P. Now this is outward. Again the same thing, in case of positive charge the electric field is pointing outward. So this is the picture of your electric field at a particular point due to a dipole in case of axial line. So E1 electric field due to minus Q, E2 is the electric field due to plus Q, and E is the resultant electric field at point P. Here E means the resultant electric field, the electric field that you are going to find at point P due to both the charges. Taking the help of electric field formula, which was F divided by Q, I have E1 as 1 by 4 pi epsilon naught Q divided by R square. There we had R square. Now out here R square is the distance from A to P. This is the distance R square from A to P. Since in the case of E1 it is minus Q, that is producing the electric field at point P. Hence we take R square as AP square in the case of electric field by E1 at point P. So out here, what is AP? It is x plus A whole thing square. And how is it x plus A whole thing square? Since this entire distance is twice A. So half the distance is A, and this distance from the origin till point P is x. Therefore, it will be x plus this distance, which is A. So it becomes this whole distance from point A to point P becomes x plus A. So it is x plus A whole thing square along PA, along PA. It is on this direction. And then for E2, it is 1 by 4 pi epsilon naught Q divided by R square. So in this case, R square will be your BP. Since E2 is the electric field produced by plus Q at point B. Therefore, that distance, the R square distance in this case will be BP square. What will be BP square? It becomes this distance, which is this total distance from the origin O is how much? X. And this is the extra term that is coming into picture. An extra distance is coming into picture, which is A. A is the extra distance. So since an extra term A is coming into picture, so it becomes x minus A. Again the same thing, whole thing square. Okay, this is how I got AP and BP in the case of R square, and I put down that thing into the formula, which is 1 by 4 pi epsilon naught Q divided by x minus A whole thing square. Please remember this. Here is a missing term. So if there is something missing, what we do? We add up. And when something is extra, what we do? We subtract. Okay. So same thing is being applied out here. So this is along PB. It is along PB. So we got the expression for E1 and also for E2. Now our aim is to get an expression for the resultant electric field. In this case, E2 electric field E2 is greater than E1. Out here in this case of E1, the denominator is increasing. It is x plus A, it is adding up. Hence the denominator increases, which results in the decrease of E1. Here the denominator is increasing, hence the E1, the electric field E1 is decreasing. Whereas in the case of E2, it is x minus A. It is subtracting, means it is the denominator is decreasing, and when denominator decreases, E2 is going to increase. This is how E2 is greater than E1. So the resultant electric field E is going to be E2 minus E1. So the resultant electric field becomes E2 minus E1. Now putting all those E2 and E1 in this particular form, that is by substituting E2 and E1 out here, it becomes Q divided by 4 pi epsilon naught 1 divided by x minus A whole thing square minus 1 divided by x plus A whole thing square. So what I have done out here is I have taken Q divided by 4 pi epsilon naught as common terms. So doing all the calculations out here, what I get is 4ax divided by x square minus A square whole thing square. So this is coming from your A minus B and A plus B, which becomes A square minus B square. And then what I do is I rearrange things out here in such a way that I can get the electric dipole moment. What I do is I divide this 4 into 2 parts. 2 into 2 will be 4, so it becomes 2. I'm going to place it here. It becomes 2AQ. 2A and Q. I'll place it here and what I am left with is twice x. So this becomes 2aq twice x. And then I know the electric dipole moment is twice aq. Therefore, I replace this twice aq by 2p. This is the expression for the electric field produced by this dipole at point P. The direction of the electric field is from here to there. There is one more case that we have to take into consideration, which is for short dipole. Short dipole means when this length is extremely small. Okay, as I had said earlier, A tending to 0 for an ideal dipole. So if this is very small, if this distance between the dipole is very small, then this distance from the center to the point P is going to be larger. Hence what we can do, we can neglect this distance. We can neglect this distance. So neglecting that distance, what happens is you are going to neglect this A. In this expression, you are going to throw out this A. So when A is very less than x, throwing out A, it becomes 2x divided by x to the power 4. This is x square. So square into 2, it becomes 4. So x to the power 4. Okay, and then the resultant form becomes this. Electric field will be equal to twice P electric dipole moment divided by 4 pi epsilon naught x to the power q. Writing it in vector form becomes E is equal to 2p divided by 4 pi epsilon naught x q. Please remember, for short dipole, that is A very less than x, electric field is inversely proportional to the x cube. This is what you have to remember, and also the direction of the electric field is from this side to this side.